A car started from rest. So if we started from rest, look at rest. Here, velocity. This is time. So it started from rest. That's at the beginning. And at rest, when it's at rest, its velocity is 0. It's not moving. So it started from rest. Accelerated constantly at 3 meters per second squared. It has an acceleration of 3 meters per second squared. It's accelerating. That's why the line is inclined. Accelerated for 3 meters per second for 20 seconds. It accelerated for 20 seconds. Let's say this is 20 seconds. It accelerated to 20 seconds. So according to the question, so it then traveled at the velocity reached for 40 seconds. So it traveled at this velocity. At this velocity reached. That's we are not told the velocity. We will get it for 40 seconds. That's about, let's say about here. It traveled for 40 seconds. That is 20 plus 40. That is 60 here. This will be 60. It traveled for 40 seconds. That's what the question said. From at 20, it started traveling at that velocity, 40 seconds. It came to rest with a uniform retardation, deceleration, after 12 seconds. So it came to rest after 12 seconds. That's somewhere here. It came to rest. So 12, this will be 72 seconds. That's plus 12. This is 12. It came to rest. Look at how the diagram. Look. It accelerated and then continue in that velocity reached in that acceleration. Look at it. That's what the graph is showing. Then it now come down to stop. It did this accelerated for 20 seconds. Now continue in this velocity reached for 40 seconds. Now came to rest in 12 seconds. And that is this. So the next thing now is to get this. This is just 3 times 20. Because that is, we know that velocity is equal to acceleration times time. Which the other, if you use the first equation, v equal to u plus 80. U is 0. It started from rest. So 80, 20 times 3, which is 60 meters per second. So we have gotten the velocity, which we marked. We have gotten the velocity. Now, if the question now says, the question now says, find from the graph, calculate the distance traveled by the car and its deceleration. So to get the distance traveled, it's simple. The area of this trapezium. The area of this trapezium. The area of from here to here is 40, which we have 40 plus 72. The whole of this is 72. Area of a trapezium times the height, in this case, which is 60 over 2. Very simple. That gives you the total area, the total distance traveled. The total distance traveled. The total distance traveled, which in this case is 3360 meters. 3360 meters. 3360 meters. That's the total distance. 3.36 kilometers. That's the total distance traveled by, on all these things we talk about, that's the total distance traveled by this vehicle. Just get the area. You can as well get the area of this triangle, first triangle, which is 20 times 60 over 2, plus the area of this rectangle, which is 20 times 40. Then plus this, which is 12 times 60 over 2. Simple. You add them together, they'll give you this. That's the area of that's the total distance traveled. But to get the deceleration is here, which in this case is the velocity divided by time. Velocity there is 60 divided by time is 12 seconds. 60 divided, the deceleration there is minus 60 divided by 12. 12 is the time, which is 5 meters per second squared, which is 5 meters per second squared. Simple. So the question, let me repeat the question. A car started from rest. A car started from rest. Accelerated constantly at 3 meters per second squared for 20 seconds. It then traveled at the velocity reached. this velocity reached. It traveled at this velocity reached. It then traveled at the velocity reached for 40 seconds. 40 seconds. It came to rest with a uniform retardation. After 12 seconds, it came to rest. Look at it. 12 seconds, it came to rest with a constant deceleration. After 12 seconds more, sketch a velocity time graph. That's what we sketched. A velocity time graph of the motion. Look at the graph of the motion. From the graph, calculate the distance traveled. That's the area of this trapezium by the car, and the deceleration, because this divided by the time. That's the deceleration. And that's what is on the board. We have gotten the total distance traveled by the car and the deceleration. Thank you very much.